I think as part of the demo that we wanted to showcase, wherein the GAS vulnerabilities are pushed to JIRA and also the integration with the ID in Visual Studio Code, right? To showcase that, we have a repository in GitHub called Mona Gallery, and we have subjected it to depend about code scanning and secret scanning scans. And as you see, there are quite a few vulnerabilities which has been identified. Um, on this repository, we have also installed the Jira app, the security app, which will pull vulnerabilities from this repository into the Jira security dashboard, as you can see here. Uh, under under your this is a project GAS vulnerability within Jira, and then security dashboard, and these are all the vulnerabilities, secret scanning, dependabot, and code scanning, which is being pulled from the Mona Gallery repository. And the integration is facilitated, as I said, by the app which is installed on the repository. It's called the Jira app, right? Okay, so this was the first part of the integration, wherein the Jira Marketplace plugin got installed in the repository in GitHub, and then we enabled the Jira security dashboard. And with this, all the vulnerabilities that were reported post scan, like a security dependabot and the code scanning, all the vulnerabilities were pushed into Jira. Now, the other part of it is the ID part, right? So now we have opened the code space. In the code space, if you can see, this is my repository, the same repository which I have shown you earlier, right? So we have the Mono Gallery repository. Uh, One of the plugin that we need to install to facilitate this integration is called the GitHub Security Alerts. Okay, so this plugin will basically pull up all the dependabot and the code scanning alerts on that repository into the IDE. Um, so how do you view it? So since I've already done the code QL and dependabot scan, and the plugin is also installed, so we go to GitHub, the left pane, and then you have this pane called the security tab under uh, under the GitHub icon, right? You have the security wherein it shows 34 dependabot alerts and 9 code scanning alerts that has been identified, which matches our uh, findings in the GitHub repository. We say 34 dependabot and 9 code scanning alerts. So now what you can do is, as a developer, once he or she starts analyzing these dependencies, right, and other vulnerabilities that has been reported within the IDE space, let's take a low severity vulnerability, right, um, which says OpenSSL included in. So this is a vulnerability OpenSSL included in cryptography wheels. So this is a description of the vulnerability, right? So now after your analysis, you can open the link. So it will take you to the corresponding vulnerability within GitHub itself, and as a developer, you can start drilling down into the vulnerability as you want to understand the vulnerability and what remediation action can be taken, right? As part of this analysis, it might very well happen that you feel this vulnerability might not be uh, relevant to you, right? It might not be relevant to you. So there is a possibility of dismissing alerts right from the ID itself. So if you see here on the vulnerability that I've highlighted, the low severity vulnerability, you can right click on it and say dismiss alert. And you can say that, give the reason. It says a fix has already been started, no bandwidth to fix, risk is tolerable to this project, this alert is inaccurate or incorrect, or vulnerable code is not actually used. So it, I'll go ahead with the reason saying risk is tolerable for me, right? Now, if I go back to GitHub Advanced Security Dashboard now, under Dependabot, let me refresh the screen, right? Earlier we had 34 issues, vulnerabilities in the Dependabot. So if you see now, one has been closed. You see, it has been closed, a low risk, right? and the reason is risk is tolerable to the project. Now let's see how it translates to Jira, right? Does it get reflected in Jira as well? So let me search, let me refresh Jira in this case. Mhm. Let me see if something is closed here. Okay, so if you see here, we from the ID we closed like we ignored this vulnerability, saying vulnerable OpenSSL included in cryptography will, right? We ignored this and it showed up as closed in our security tab under the depender bot, right? So now if you go to Jira now, so it's a similar thing, reflects in Jira, the same status. Um, what you filtered on is on based on ignored, right? So this is an ignored vulnerability, and we see this vulnerability being ignored in Jira as well, and then it takes you back to the same vulnerability description within GitHub. Okay, so as we saw, so we had a dependabot vulnerability, low severity vulnerability, which was reported post a scan in GitHub security dashboard. Uh, the same vulnerability got pushed into Jira as a under the security dashboard in Jira. So next, what we did is we took up the ID integrations with the gas security alert plugin, which pulled out the dependabot vulnerability and the code scanning vulnerability into the IDE. We dismissed the alert in the IDE, which changed the state of the vulnerability in GitHub, um, marking it as saying its risk is tolerable to the project. And in turn, with this the status being updated in GitHub from the IDE, the same state got reflected in Jira. And we have a, uh, let me open up this vulnerability ignored. Because we have not actually closed it, we have just ignored it. So we see the vulnerability as ignored in Jira. So this is the complete end-to-end flow, wherein vulnerability from IDE got fixed from the IDE got propagated to GitHub. From GitHub, the status got reflected in Jira. Now let's move to the next stage. So what we'll do is we'll try to fix a code scanning vulnerability and see how that propagates from the IDE to GitHub and then to Jira as well. So for this, let's take SQL injection vulnerability that is reported, right? If you see, once I've clicked on the high and the query database query built from user control input. So this is typically a SQL injection vulnerability that how it's manifesting, right? It also gives you the details on what the vulnerability is and explanation of how to fix it, right? Um, Now what we'll do is first thing first, we need to create a bug fix branch. We'll create a new branch from main. I'll get named SQL injection fix. Okay. Okay. So now we are in the SQL injection fix branch. And if I can go to my securities, right? So now if you see, this is the place where the vulnerability manifests itself. Like we are taking the user input and they're using all the user input are directly appended in this query string. The recommendation to fix SQL injection is to use prepared statement. So now let's use Copilot to ask for a fix for this particular uh, vulnerability. So what we'll do is Copilot. Okay, we'll go to chat. We'll ask fix I'll say propose a fix for this highlighted SQL injection vulnerability. Okay, so let's see what recommendations Copilot comes back with. Okay, so if you see here now, instead of using a directly appended query set, it's using a prepared statement. So we will copy into my this recommendation into my source code on the right. Okay, and once if we have now that we are happy, we will commit this with a commit message fixing SQL injection and do a commit. Yes. Okay. I'll say publish branch. Okay. So if I go back to my repository now, let's go to Mona Gallery. I should see this SQL injection fix branch already there. Now, either as a developer, as a next step, right? What would be the process step is logical step is creating a merge request, a pull request, and then merging the changes back to the main branch, right? So instead of doing it from the UI, you can start doing it from the ID itself. How do we do it? Now let's go back to our ID. If you see here, it says create a pull request. Do you want to create a pull request? Yes, I want to create a pull request from SQL injection to the main branch. I'll give it, you can optional description, fix the reported, and then I'll do create. Okay, and then you can see this pull request being the details of the pull request showing up in your ID itself, right? So what happens in the backend is if you go to gas depend bot or go to actions, no, sorry, it's triggering a scan. So basically, it will again scan through your source code and give you an insight on the vulnerability posture for that particular for that particular feature branch, right? Because we are creating a pull request, it will show you are there any new vulnerabilities which are uh, incorporated, which got incorporated with this code change, right? Or has it fixed any existing vulnerabilities, right? So let's wait for this to get completed, the scan. So if you see now, this PR, all the checks have passed because there is no new vulnerability which has been identified with the code change that has been proposed, and we're ready to merge the pull request. So either you can merge it from the GitHub UI, or you can merge the pull request from the ID itself. If you see here, uh, all the checks, or four success checks and one pending. Let's refresh it. Okay. So now we'll go ahead and merge the pull request. Merge commit. Okay. So what this will do is in our GitHub, if you see, it's the same merge is reflecting in the UI itself. So this will trigger a final scan on the main branch to get the updated list of the vulnerabilities or the outdated posture of the security. And ideally, in this case, uh, the fix that we propagated for the SQL injection from our SQL injection feature branch, right? Since now it's propagated into the main branch, post this scan, we should see that particular vulnerability getting closed in our GitHub security dashboard as well. So we should see uh, 8 code scanning vulnerabilities because with one closed vulnerability because of the code change that has been done. So we'll wait for the final scan to get over. So now if you see the final scan got completed, um, and then if we go to our security tab now in here in our GitHub UI, so if you see now earlier we had 9 code scanning alerts, so it came down to 8, and with one closed vulnerability, which is the database query built from user controlled sources, and it is marked as fixed because the developer has actually fixed the code in the IDE, propagated it into a SQL injection fix branch, created a pull request into the main, and then in the main, the final scan confirms that the fix has actually been propagated and it's fixed and it's closed up in the GitHub UI in the security dashboard. Similarly, now if ideally this closed status should also reflect in my Jira security dashboard as well. So now let's see if it really does reflect the status in Jira security dashboard. If I go and scroll down to that particular vulnerability, it says database query built from user control sources, and it is marked as closed, right? So if you see here now, it'll take me back to the original GitHub vulnerability in the GitHub UI, right? Okay, and the vulnerability is marked as closed in the issue, which got which we assigned to this particular vulnerability. So this is how the integration and data flow can happen for the gas vulnerabilities from an ID to GitHub, a scan happening in GitHub, and then data getting pushed into Jira, which is the centralized ticketing system for many organizations which they use.